In Chapter 17 of Let's Code Test-Driven JavaScript, we spend a lot of time and effort on getting Karma to work with CommonJS modules. But why bother? What's the point of going to all that work when it's so much easier to just use something like Mocha or Jasmine and load a test page in the browser? Hi everyone, my name is James Shore and this is Let's Code Test-Driven JavaScript. I'm here with my lessons learned about large-scale JavaScript development. In this episode, we're going to take a look at two of the fundamental challenges that arise when developing non-trivial JavaScript applications. The first issue is the need to support multiple browsers. For any serious effort, you need your application to work on a wide range of browsers, and you need to catch errors right away so you don't spend a lot of time reworking code to work cross-browser. The second issue is that you need to organize your code base and divide work among team members. That means that you need to divide your code into multiple files and have some way of having those files depend on each other. You also need development to be fast. This is one of the most important issues for productivity, and it's often neglected. We need a really tight feedback loop. Programming requires so much precision. It's essential we be able to check our work every minute or so, and in order to do that, we need really fast feedback. If we don't have it, development slows down or we write more bugs. It's just that simple. So that's what this episode is about, the fundamentals. We're not going to talk about architecture, design patterns, frameworks, and so forth. That stuff's important. Well, to be honest, design fundamentals are way more important than architecture, but that's a rant for another day. We're not going to talk about architecture and design today. Instead, this episode is about getting the fundamentals right that enable you to do good design. I've got 4 brief chapters for you. First, we're going to look at using Karma to solve the cross-browser testing problem. Second, we'll review CommonJS modules and Browserify so we can solve the modularity problem. Third, I'll show you the Karma CommonJS bridge I developed to make those tools work together. And last, we'll look at a cheat sheet for putting it all into practice on your own projects. I've produced a simple drawing application to demonstrate the concepts in this episode. You can find source code at the link on your screen. If you'd like to see more, check out the live channel where we go into depth on developing a real production drawing application. Let's start with the issue of cross-browser testing. I think it goes without saying that cross-browser testing is essential. Even if you're working entirely with modern browsers, you still have some differences, and the chances are good that you're not working entirely with modern browsers, or you have some need to support mobile browsers. Whatever set of browsers you're using, of course, you need to make sure that your application works on all of them. And as I said in the introduction, speed is essential. We're looking at validating your work every minute or so absolutely cannot do your testing manually. I mean, you could, but there's no way to get that fast feedback, which means that you're probably going to introduce more bugs because you're not testing your work in fine-grained cycles. So the first thing we need if we're going to do cross-browser testing is an automated tool. Second, we need a tool that is going to support long-lived browsers. We need the ability to start all of our browsers at the beginning of the workday, capture them, and then run our tests against those browsers without restarting them. There are tools out there that will start the browsers for you, run the tests, and then shut down the browsers, but that takes too long. If we're running our tests every minute or so, we need our tests to run in less than 10 seconds, preferably less than 5 seconds. And spinning up all these browsers can take many seconds on its own, not to mention being really difficult when you're talking about cross-platform testing, like running IE on a Mac or running Safari or iOS Safari on Windows. Third, we need an approach that emphasizes unit tests. Unit tests are much faster than other kinds of tests, so we need lots and lots of unit tests. We still need to have some focused integration tests and some end-to-end integration tests, but our emphasis needs to be on unit tests because those are the fastest types of tests to write and they're the ones that are easiest to maintain as well. My preferred tool for all 3 of these things, automation, browser capturing, and a good support for unit testing as well as the other types of testing, is Karma. There are other tools out there like Testim Scripts and I think Buster.js. There's also JS Test Driver, but Karma is my current preferred approach. The way it works is you start the Karma server from the command line or from your build script, and then you capture your browsers. You point your browsers at a local URL that it provides. That can be done over the network or it can be done against localhost. And those browsers just stay up and running all day long or even all week long if you like. You also need source code and tests, of course. And when you have everything ready to test, you run a command which will tell the Karma server to load your source code and send it out to all the captured browsers. The browsers will run your tests inside the actual browser, verifying that it actually works in the real browser, and report back the results back to the runner, which will collate them all, give you the answer with an error code, which is really great for automated builds because you can have your Karma tests run as part of a larger build, which is what I have it doing in the example source code. Let me show you an example of how this works. I'm in the directory for the example source code for this episode. And what I'm going to do is I'm going to run the build script and tell it to launch Karma like that. It's going to go ahead and load up Karma and create a server at localhost 9876. Next thing I do is I launch the browsers I care about, which in this case is going to be Firefox, Safari, Chrome, mobile Safari running in the iOS simulator, although I could run it on real hardware and connect over my network, IE8, and IE9. Once I have all of these browsers captured, I can just leave them running all day long. I don't have to go through the time and trouble of restarting them. I just leave them going. Then I open a new command prompt, switch to my source code, and run my tests. And there you can see everything running, and in this case, it all passes. Notice how fast this is. I can run the tests with basically a single command and have an answer about how well my code is working within literally seconds. And this is what I mean by needing really fast feedback. I'm going to be coding, I'm going to flip over to this browser window, run the tests, and go right back to coding. It doesn't interrupt my flow. And that's really important. You can see that in action on the live channel where we're doing a lot of real live development, and I'm constantly switching back and forth between development, running the tests, and back. And the tests are so fast to run and so seamless and so easy to get going that it's never really an interruption. The focus is on the code and whether or not it works, and the test is just confirmation. In addition to being able to test our code cross-browser and have that happen really quickly, we also need the ability to structure our code. In a large-scale system or a large-scale JavaScript development, we're going to have multiple people working on a non-trivial application, which means that all the different pieces of that application need to be divided up into files for ease of organization, ease of development, and so people can work on different things without stepping on each other's toes. CommonJS modules is my preferred approach to solving this problem. It has an elegant syntax and a pretty simple implementation. Now, it's not the only approach to modularity. Another really popular approach is AMD. And actually, if you check out Lessons Learned number 14, I go into different modularity approaches in depth in that episode. But let me just give you a quick overview of CommonJS in this episode because it is my preferred approach. In the CommonJS module format, every file is automatically a module. To import a module, we use the require function. We pass in the relative path to that file. And to export, we just assign things to either the exports object or to the module.exports variable. Again, for details on how that works, check out Lessons Learned number 14. Here's an example of how that works. This is based on the source code that comes along with this episode. What we're doing here is in our drawing application, we have a drawing area module, which is responsible for sort of initializing everything and making sure everything fits together. It's going to require an HTML element module and an SVG canvas module. And you can see it requiring it here. And then it exports the initialize function in the center there. Now, require, exports, and module are not real JavaScript variables. They don't actually exist in JavaScript without you defining them. And the way CommonJS works is that it sort of provides those variables behind the scenes for you. What you do is you run a build, you run a script, which I put into my build file, which will take all of your modules and wrap them up in a special CommonJS wrapper and combine all those files into a single file, typically called bundle.js, at least if you're using Browserify, which is the tool I'm currently using for CommonJS. Here's an example of that build. Again, you can find this in the source code that goes along with this episode. What you're going to do is install Browserify and then require it in your build script. And then you can tell Browserify to bundle up whichever files you like. See the Browserify documentation for details on that. The CommonJS module format has a couple of problems. First, it does require that build step, and some people see that as a criticism. I don't really have a problem with it because if you're doing large scale JavaScript development, you're almost certain to have some sort of build step for other reasons. So it's not like adding Browserify or some other tool to your build is a big deal. A more significant issue, though, is that because Browserify or whatever tool you're using is going to combine all your modules into one file, any stack trace or other error messages you get out of your code is going to point to lines in that huge file. So when you're looking at errors in the browser or in your tests, you're not really seeing where the code comes from. Now you can resolve this using source maps in the browser, but it doesn't really solve the problem of what you get when you're testing. The other issue is that, remember, we're running our tests all the time. But if we have a large application, running Browserify or some other tool to combine all those files together before you test can actually get pretty slow. Remember, our target is less than 10 seconds, preferably less than 5. That's not a whole lot of leeway for combining files together. That, combined with a lack of good stack traces from your tests, is a real problem. And that's why I created the Karma CommonJS bridge. The Karma CommonJS bridge is a tool I created to add support for CommonJS to Karma. And then one of the chief maintainers of Karma, Wojciech, I hope I pronounced his name right, he took that and turned it into a Karma plugin for the new Karma 0.10 release. Here's what it does. It takes all of your modules, and rather than combining them into a single file like Browserify or another production tool will do, instead it wraps each individual file in a little CommonJS wrapper in a preprocessor. So right when Karma loads your files to send them off to the browsers, it wraps them in this preprocessor, which provides the require, module, and exports variables that CommonJS needs in order to work. And then behind the scenes, it has some implementations of those functions. So what happens is that you don't have to recombine all of your files when you run it, and you get the right stack traces out of Karma. Here's how to use it. First thing you're going to do is install karma-commonjs, and then you need to update your Karma config file. You need to add the CommonJS framework to your frameworks line, which is going to be in your karma.conf.js. And you'll also need to add the CommonJS preprocessor to any files that use CommonJS. For the example that I've got along with this episode, they're all in the CommonJS directory. You, of course, might have them somewhere else. Be sure to restart Karma after you update your config file. So let's put it all together. There's 3 things we need. Karma, the way you can install that is by doing npm install karma. If you want to use Mocha with Karma, you're going to also need to install Mocha. Then you create the Karma config file. The easiest way to do that is to run karma init. I've got the Mac and Unix syntax on the left and the Windows command on the right. Then once you've got that started at the beginning of your workday, you're going to start Karma and capture browsers. And then whenever you want to run your tests, you'll tell Karma to run your tests. It's also quite likely that you'll want to have this set up in your automated build. And for an example of that, see the source code for this episode. For CommonJS, I like to use Browserify. You can install that using npm install Browserify, and then all of your files automatically become modules, and you can import and export using the require function or the exports and module variables. Then to make these 2 tools work together, install karma-commonjs. Be sure to update your karma.conf.js to specify the CommonJS framework and to tell Karma which files are going to use the CommonJS preprocessor. So why did I spend all that time and effort on getting Karma to work with CommonJS modules? Well, it's because for large-scale JavaScript development, we have 2 things that are really fundamental. First, we need to run our tests across browsers, and second, we need some way of splitting our code into multiple modules and coordinating those modules together. It's also important that everything run really fast, and that requires a focus on unit tests. So my preferred solutions are Karma for really fast cross-browser testing using a lot of unit tests, CommonJS to divide everything up, and then the Karma CommonJS bridge to make it all work together. And that's what I've learned so far about large-scale JavaScript development. You can find example source code for this episode at the link on your screen. Thanks for watching, everybody, and I will see you next time.